Hi guys, this is the key for the factor label practice questions 11, 12, and 13. That's another 11. It's nice to know that I still can't write numbers, isn't it? I think it's really comforting. Okay, 12 and 13. So we'll start with number 11. And this is a little bit tricky because they present it as some type of percent by weight problem. However, it actually truly is a unit conversion issue because it's asking us to figure out the mass of the H2SO4, and it's telling us 55 milliliters, which is a volume, and they want to know how many grams that is. And then they also mentioned to us that only 96% of that mass of 55 milliliters is actually the H2SO4. And so that 96% will kind of come into play at the end. The first thing we need to do is get from milliliters to grams. And right away, that gets me thinking about density, because density is grams per milliliter. If you look at the top of your factor label practice sheet, there is a density listed for sulfuric acid. And so we can use that density to solve for the number of grams. Once we have that, then we can use the percentage to find the mass of the sulfuric acid. So my starting point will be my 55 milliliters, and you may have noticed that your density, for hydrogen sulfide sulfuric acid is in really weird units. So they give it to you in the units of 8.45 times 10 to the 9th tons per mile cubed, which is just kind of nonsense, really. And so we're going to have to deal with that, though. So the first thing we need to do is get our milliliters into miles cubed. Once we've done that, we can switch from a volume to a mass, and then we'll need to change our tons into grams, but one thing at a time. So let's go ahead and start with our 55 milliliters. And so I need to get from milliliters to miles cubed. So I'm thinking I want to go from milliliters to centimeters cubed, and then I can go centimeters to miles cubed. And I'm going to use a lot of things from your cheat sheet, a lot of conversion factors from your cheat sheet. So 1 milliliter is equal to 1 centimeter cubed. And now I'm going to start converting my volumes to miles cubed. So that means that 16.39 centimeters cubed is 1 inch cubed. Basically what I did to come up with 16.39 is I took the 2.54 centimeters equals 1 inch cubed, and I cubed the whole thing. So 2.54 cubed gives us 16.39 centimeters cubed. Then we can take 12 inches cubed in a foot. So 12 cubed is 1728 cubic inches in 1 cubic foot. And there's 1.47 times 10 to the 11 cubic feet in a cubic mile. So that's just really over the top. And I just took my normal conversion factors and I just cubed them. So for the centimeters to inches, 2.54 cubed. For the inches to feet, 12 inches cubed. And for the feet to miles, 5280 cubed. All right, so now we've got our miles cubed on top, so we can use our conversion factor finally. I'm just going to keep going on this same factor label line. So I'm just going to take this, I'm just going to keep going with that, even though I ran out of space. So now my next move is to get my miles cubed to cancel out. So 1 cubic mile is equal to 8.45 times 10 to the 9 tons. Looks like I didn't give myself enough room, so I'm just going to erase that line. Oops, and make my square bigger. Okay, so now we are officially in tons, which means we're in mass, which is great because we're looking for grams. Now I just have to go from tons to grams. So to do that, I'm going to use 1 ton is equal to 2,000 pounds, and 1 pound is equal to 454 grams. Oh, hello, keyboard, go away. All right, now I'm in my desired unit, which is grams. So I can say that this solution of sulfuric acid, 55 milliliters of that solution has a mass of 101.36 grams for 55 milliliters of that solution. They tell us that only 96% of that mass is coming from the H2SO4. And so now what we really need to do is take our solution, which is 101.36 grams, and multiply that by 0.96. So we're multiplying by that percentage, and that's going to give us the solution of 97.3 grams sulfuric acid is the weight contributed by the sulfuric acid itself in that solution. Okay, so yeah, a little bit tricky. Ultimately a factor label problem, but it's a little bit indirect, and that's totally fine. That's why it's in the hard section. Okay, now on to number 12. So number 12 is asking us to go from a pint of alcohol, and it's saying that 70% of that solution by volume is actually the alcohol. So we'll start in pints, and we want to get to milliliters. It's asking us about milliliters. And so this is, again, just unit conversion from pints to milliliters. And then we can use that percentage to find the final volume. Okay. So I'm starting with my 1 pint. And, you know, looking at the conversion factors that I'm given, I can take pints to 16 fluid ounces, and then I can go fluid ounces to quarts, quarts to a gallon, gallon to a liter, and liter to milliliters. So that's kind of how I'm planning this out in my head, just based on looking at my cheat sheet. I kind of just go one at a time. So I'm like, all right, I know that, excuse me, I don't know how to lock this, so it just keeps scrolling everywhere. 1 pint is 16 fluid ounces, and fluid ounces are different than weight ounces. So kind of keep an eye on that. That can trick people up sometimes. 32 fluid ounces is equal to 1 quart. There's 4 quarts in 1 gallon. And there's, in 1 gallon, there's 3.785 liters. Let me keep going on my same line. And last but not least, in 1 liter, there's 1,000 milliliters. Milliliters. And so then that gives us 473.13 milliliters as our solution. And we know that only 70% of that is actually the alcohol. So we can do for 73.13 milliliters times that 0.7, that gives us 331.19 milliliters. The solution on the paper is like 330. This to me is just a rounding difference. As long as you show your work, oh my gosh, I keep yawning, sorry guys. As long as you show your work, you'll be fine, right? That's definitely close enough for me. Okay, last question is actually much easier than it looks. For number 13, you can take your 250 grams of solid boric acid and multiply by that by the 2%, 0.02. It's going to give us 5 grams of boric acid. So that one was sort of deceptively easy after 11 and 12. Okay, hopefully that helps. Please feel free to comment with any further questions about the factor label worksheet. I will take a look at those comments again Wednesday morning and post some more solutions if we need them. Thanks, guys.